Now the third question, the weights in grams of harvested cucumbers on a certain farm are categorized in the table below. So here we have weight in the top row and we have frequency in the second row. Determine the range of the weights. No. So the range would be the largest value minus the smallest value. So the range the largest value. No, the weight, no, the largest weight now. We just have to assume that there's a weight, it's 1201 to 2000. So the largest possible weight there would have been 2000. And the smallest possible weight would have been there 250. So the range is 2000 minus 250, which is 1750. So 1750 grams. Part 2, state the boundaries of the class with limits 501 to 900. That's this one. So to get the lower boundary, we subtract 0.5 from 501. So we're left with 500.5. And to get the upper boundary, we add 0.5 to the upper limit. So that will be 900.5. Calculate the probability that a cucumber selected at random weighs more than 900 grams. So the probability, so let's look for the amount that weighs more than 900 grams. So more than 900, so if we here from, so 900, so 900 from more than 900 will be here, 901, that's 210. And this also, this other 102, also that's more than 900. So 210 and 102, so the probability, 210 plus 102 over the total frequency here, the total number of cucumbers. So 210 and 102, and of course the total would include the 300 and the 420. So 210, 102, 210, 102 plus, what were the others? 300 and 420. That's 720. If we just add up the numerator, that would be 312 over, and we add up these four numbers in the denominator to get the total number of cucumbers. That's 1032. So if we use let me use 3 decimal places, 0.302 would be our probability. Calculate the estimated mean. So for the mean, I'm going to use the formula. So the mean equal sum of fx over sum of f, or n, and we know that the sum of the frequencies, we just calculated it to be 1032. We just calculated that to be 1032. So we need now the sum of f times x. Alright, x. So in this case, we have limits, class intervals. X would be the mid-intervals. Alright, let's work out the mid-intervals. That's what we call x. So the mid-intervals. And to get the mid-intervals, we can simply just average the two limits here. So we add 250 and 500 and divide by 2. We get 375. I'm going to put the mid-intervals here. So I'm going to put the x here. Our mid-intervals. This would be, for the first one, it would be 375. And how we get the 375? Just average the two limits here, 250 and 500. 750 divided by 2. Add these and divide by 2. We get 1401. 1401 divided by 2. That's 700.5. Add these, 901 and 1200. Add them. We end up with, what's this now? 1100.01. So divide by 2, we get 1050.5. Add these two limits, we get, what now? 3,201 divided by 2, we'll get 1600.5. So these would be our mid-intervals representing x, so we use a mid value there. So sum of fx, so fx, so this by the, so f by the f with the number of cucumbers here. So fx, so let me do a fx column, fx well. Row there, fx. So I put fx in this row here, which is a frequency times the mid intervals. Let's do the calculations. So 300 times 375, that's what? That's 112,500. Next, 420 times 700.5. That's 294, 210. And second to last one, 210 times 1050.5. That's 220, 605. And the final one, 102 times 1600.5. That will give us 163,251. That's the fx values. So we need the sum of the fx values. So we're going to add up all these fx values, the values in the fx row there. So 112,500 plus 294,210 plus 220,605 plus 163,251, and I'm getting 790,566. So 790,566. So the sum of the fx is 790,566 divided by the total number of cucumbers, which we can get by adding the frequencies. So divide by 1032, and I'm getting 766.05. And what was it? Unit? Was it grams? Unit was grams. All right. So grams. Next, the data below shows the waiting time for 25 patients to see a doctor at the accident and emergency unit within a hospital. And there's values for the 25 patients from 8 to 29. The minimum, quartile, median, third quartile, and maximum of the data were 8, 18, 30, 36, and 50 respectively. However, the median value was incorrect. Determine the correct value of the median. Now, to get the median, we have to put the number in order, whether ascending or descending. So let me just rewrite these 25 numbers in order. And if it's 25 numbers, of course, the median would be the 25 plus 1. That's 26. So the median would be the 13th number. 26 divided by 2. So the median would be the 13th number. Since it's 25 numbers. Let's write out these numbers. So the smallest number here was, what, 8. Just that's the smallest number there, so it's 8. And then what's the number follows 8? Is there a 9? Yeah, we have a 9. 9. Is there a 10? No. Is there 11? No. 12? No. 13? Is that 13? Let's circle it so as to not. So I can still see the numbers. So we have 8, we have 9, we we have 13. Is there a 14? Yes, there is a 14. Is there a 15? No. Is there a 16? Is there a 17? So 17, 18, 19, 20. We are 21 is there twice. There are 22, 23, 24, 25, 26. Was there a 25? No, there's no 25. There's no 25 actually, so it's 26. 27, 28, no, 29 is there twice. And no 30, but with a 31, we have two 32s there. And then there are 33. 34, no. 35, yes. Well, alright, error there. Error there, we are told this, sorry, this error there. We are told that the smallest number, the minimum number, just there. The question said that the minimum number is 8. Q1 is 18. Q2, which is a median, well, let's say the Q2, which is a median, is incorrect. We just determined the correct value. We just found it to be Q2, same as the median. We just found it to be 29. So this 30 is incorrect. Alright, so it's actually 29. And the Q3, quartile 3, is 36. And the maximum value is 50. And now we're asked to do a box and whisker diagram to show these 5 data points. So notice it runs from 8 to 50. Alright, let's see, look at the graph. Alright, it runs from 8 to 50. Let's see, can we count by 8 to 50? Let's see if we can count by to get to 50. I guess we can count. Can we count by 5? 5, 10, 15, 20 easily. So 0, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I'm using a 1 to 5 scale here. So let's look at the data points now. So the minimum is 8, the maximum is 50. Alright? So the minimum is 8. 8 will be, so each thin line would be represent 1. So 8 would be just 2 thin lines before the 10. So let me do it here. So 8 would be here. So this is the minimum. The maximum here, the maximum is 50. Alright, so that's the minimum, which is 8. The maximum is 50. Let's put in the quartiles now. So the quartiles So we have a minimum and maximum already. The quartiles, 18, 29, and 36. So 18, 29, and 36. So 18, that's 2 before the 20. 29, that's 1 before the 30. And the third quartile was what again? 36. 36, that's 1 after 35, right? Alright, so of course you'll use a ruler. I'm using freehand there. Of course you'll use a ruler. So draw a line there at 36. One there. So the box will have all the quartiles. Alright, so 18. That's 2 before the 20. Alright. So the box will have all the quartiles. And use a ruler, by the way, to draw this box. And the median, which are the second quartile, is 29. That's 1 before the 30, right? So draw a line there, and of course ruler. Let's overemphasize ruler. Alright, and I draw a line now from here to the largest value, here to the smallest value, minimum. So this is the minimum value, which was 8. Maximum value, which was 50. The first quartile, which was 18, Q1. The second quartile, or the median, Q2, was 29. And the third quartile, Q3, was 36. Alright, so that's our box and whisker diagram. And remember, all of these lines, everything here, must be drawn with a ruler and a pencil. Alright, not freehand like what I just did. Alright, using the box and whisker diagram for, right? Describe the shape. Describe the shape of the distribution in waiting times. And of course the shape is asymmetrical. In other words, notice the median is closer to Q3. Alright, so we could say the shape, the waiting times are skewed to the right. Alright, and I've seen that most of them waited for a longer period of time, relatively. Alright, let's move on. Correlation and regression statistics are obtained for waiting time against time of visit to the accident and emergency unit. Note that time of visit to the nearest hour is measured from 6 a.m. So for example, the time for a patient who visited the unit at 10:45 is approximated to 11 hours and corresponded to t equal to 5. What is the dependent variable? Justify your response. Of course, the dependent variable would be, so dependent variable is waiting time W, is waiting time W, and the reason, since waiting time W, since waiting time is influenced or is dependent on the time of visit, is influenced by or dependent on the time of visit, and by the time of visit would be the independent variable. Alright? Now figure 4 shows the scatter plot of waiting time W against time of visit T for patients visiting the accident and emergency unit. Complete the graph in figure 4 by drawing the estimated regression line on the scatter plot. So you could draw what we call a best fit line. Again, using a ruler. And I'm using a ruler here. Well, I'm not using a ruler, I'm using freehand. But you want a line that will try to go through as many of these points or in between these points as possible. So I guess different persons would have different best fit lines, but can draw a line looking something like that. A best fit line. Alright, so that would be my best fit line. Of course, you'll use a ruler. Alright. Alright, okay, so next, take the value of the y-intercept for the regression line. Interpret this value in the context of waiting time and the time of visit. So based on a line, of course, your line would not have to be exactly the same, but something close to this. Alright, so based on my line here, notice going up by 5. So each two of these 10 lines would value 1 based on the scale here. So based on mine, this would be about 51. So it'd be about 51. And recall that waiting time was in minutes. Remember, waiting time was in minutes. So the waiting time would be 51 minutes when the time of arrival is 0. And 0 is calculated from 6 a.m. Remember in the question, where was it? Alright, so note that time of visit to the nearest hour is measured from 6 a.m. Alright, so if the time of arrival from 0, so this is from actually 6 a.m. So if your time of arrival is 6 a.m., you will actually wait. Your waiting time would actually be 51 minutes. Given that a possible equation for the regression line is W is equal to 46.971 minus 3.6202t. Calculate the estimated waiting time for a patient who visits the unit at 1700 hours. So waiting time. So W would be equal to 46.971 minus 3.6202 times time. Now, how far is 1700? 1700, that's what? 5 p.m.? How far is 5 p.m. from 5 p.m. in the afternoon? How far is 5 p.m. in the afternoon from 6 a.m. in the morning? Alright, so 6 a.m. to 6 midday, that will be 6 hours. And then another 5 hours, so that's 11 hours. So T would be 11, right? So this would be replace T with 11. So W would be equal to, I can use my calculator to do this, 7.1488, and of course the waiting time is given in minutes. Alright, let's move on to question 4. Outline the steps to obtain a cluster sample. So cluster sample, so what is cluster sampling? Of course, it's when you have a large population and you want to select a sample. So we divide. So the first thing you have to do is to identify. First thing you have to is identify your target population. Identify your target population, and you divide alright, so you divide the population into what we call clusters. or another term we could use is subgroups, and you could do it by age or by gender or by ethnic groups and so on. Alright? And after you have your subgroups, you will randomly select participants or your sample. Now select sample from each cluster. Or from each subgroup. From a population of 1,000 attendees, at a public lecture, a sample size of 30 was selected. Explain one disadvantage of obtaining the sample of selecting the 30 persons who leave the lecture. And of course, one disadvantage is you run the risk of having what we call a sampling error. In other words, you might end up with a sample that is not representing the population. A research professor is about to mark the research projects of her 8 students, among which there are 3 friends, Anne, Sugrim, Penny. Consider the case if the projects of the 3 friends are to be marked in a random order. Complete the following table to show the 6 possible outcomes. Okay, so this is you can mark Anne, then Sugrim, then Penny, or you could have marked Anne, then Penny, then Sugrim, or you could have marked Penny first. So could mark Penny first, and after I mark Penny, could mark Anne, then Sugrim, or I could mark Penny first and then mark Sugrim next and Anne last, or I could mark Sugrim first and then Anne, then Penny, or Sugrim again first and then Penny followed by Anne. Alright, so those are the possible outcomes. Should be 6 of them, 6 possible arrangements there. Alright, the professor select 3 projects to mark. Calculate the number of groups of 3 projects that can be selected from the 8 projects. Now this is a question, of course, we need to consider whether or not the order of the names are important or not. Now, based on what is happening here, the order, we're saying the order matters, the order is important. Alright? So, we're going to use 8p3, so 8. So, the number of groups would be 8p3, which is actually 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. Now 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So times 5 factorial over this 5 factorial. So 5 factorial into itself, that's 1. So we actually end up with 8 times 7 times 6, which gives us 336. And we are assuming here that the order is important. If the order was not important, then we would have used 8C3. Alright? But we're not using that since the order is important. Alright? Determine the probability that the 3 products selected by the professor are the 3 friends in the order and in the order and Sugrim and Penny. Now, and Sugrim and Penny can only come in one way. So the probability, this can only come one way. And Sugrim and Penny. So it's 1 over all the possible over all the possible outcomes, and the number of possible outcomes we just work out in part is 336, so it's 1 over 336. Part C, a random variable x has the following probability distribution. State if the random variable x is discrete or continuous. Give one reason for your answer. So the random variable x, of course, is discrete. And if you notice possible outcomes there, is finite, so x is discrete. X is discrete, because x has a finite. Notice x has 4 possible outcomes. X could be 0, x could be 1, x could be 2, or x could be 4. So x has a finite number of outcomes, a finite number of possible outcomes. Alright, in this case, x has 4 possible outcomes. So x would be, of course, discrete. Calculate the value of k. Notice the sum of all the probabilities. The sum of all the probabilities should be equal to 1. So the probabilities here, we have 0.1 plus 0.3 plus 0.4 plus k must be equal to 1. Now this is what? 0.1 and 0.3, that's 0.4. 0.4 and 0.4, that's 0.8. So k would have to be 0.2. For everything to add to give 0.1, to give 1, k would have to be 0.2. Alright? The manufacturer of a brand of milk suggests that the amount of milk Q in a box is normally distributed with a mean of 500. Is it 500 or 1,500? 1,500 milliliters. And the variance is the standard deviation square. So a variance, that's sigma square, the variance. Alright, the variance is same as the standard deviation square of 625, which means that the standard deviation is the square root of 625. The standard deviation is square root of the variance. Square root of 625 is what? Is it 25? State 2 characteristics of a normal distribution. So a normal distribution, one characteristic is that the mean is equal to the median and is equal to the mode. So for the normal distribution, the mean, the median, and the mode, they are all the same, they are all equal. Another characteristic is that the distribution is symmetric about the mean, which is saying that half the data set falls below the mean and half the data set fall above the mean. A can of milk has 1,480 milliliters. Find the corresponding Z value. So the Z value is x minus mu over sigma. So, alright, so this would be x. So x is 1480. And the mean, we're told the mean was 1500 and the standard deviation was 25. So 1500 minus 1500 over the standard deviation of 25, and this should give us negative 0.8. A second milk is found to have 1,560 milliliters with a Z-score of 2.4. Find the probability that a can of milk from this manufacturer will have more than 1560. So the probability that x will be more than 1560 is same as the probability that this z is more than 2.4. Alright, so we can use our tables for this. All right, so let's go to the Z table. So 2.4. So the Z table gives us for less than. So for when Z is less than 2.4, what we have here is 0.99180. 0.99, no, so when Z is 2.4, we have 0.99180 the probability. 0.99180. But we are doing, so it's 1 minus 0.99180. Since so this table, it gives us for less than, but the problem is asking us for greater than. Right? So if it was probability that Z is less than 2.4, would have used 0.99180. But we're working the probability that Z is actually greater than 2.4. So it's 1 minus 0.99180, which is what now? 0.00, what's this now? 92, is it? It's actually 0.82.